All right, students, let's see. I got a question here about number 10. So let me try to make another one here. I think this is a unit conversion. Let's run through it. It says, referring to table 1.3, determine the average distance between the Earth and the Sun. So looking at table 1.3, they give just a vague number of 10 to the 11th. And that's probably accurate enough. I'm going to put 1.5 times 10 to the 11th meters because I guess I know it. I could also just kind of look it up. And so that'd be a little bit better than just 1 times 10 to the 11th. But certainly in terms of order of magnitude, this 10 to the 11th is good. But I'm just going to call that the distance. And since the Earth goes around in a near circle, I'll call it on average a circle and call it the radius of the circular orbit. So this is the radius of the orbit as the Earth orbits around the Sun. Now the problem goes on and says calculate the average speed of the Earth in its orbit in kilometers per second. All right. So again, perhaps the author is a little premature here because this is a second one asking about speed, and we really don't cover speed yet. But assuming you have some connection from speed from another source, like another science course or a physical science class, the definition is how much distance did it travel in a given time. So in this case, the distance would be a circle, and so this is going to make you go back to your geometry a little bit and kind of put those two thoughts together. Okay, what kind of path does it have so I can figure out the distance, and that path then would be the circumference of a circle. And the calculation for the circumference of a circle is 2 pi r. And I'll just use the symbol T for time. But the other thing is to remember this time then would be 1 year. And so I guess that's going to take you back to, again, some other science class way back, I don't know, 5th grade, 7th grade, 8th grade, 11th grade, somewhere where you learned that the sun was the center of the solar system and that the Earth goes around it, and the definition of a year is when it goes all the way around the sun. So we know the time is 1 year. So if I were to write this as 2 pi and then r, 1.5 times 10 to the 11th meters, and divide it by 1 year, I would get some number, and I won't bother to calculate it, but looking at the units, this would be meters per year. So that would definitely be a speed, but it's not what they asked for. So they said find it in kilometers per second. So let me start with the kilometers. And so here's where the unit conversion comes into play. So I want to multiply by the number 1. I want to get rid of meters, so let me put meters down here and convert it into kilometers. Okay, and so that's the thinking. Get rid of the meters and convert it to kilometers. Now, of course, you can't just multiply by any random number. It has to be the number 1, otherwise you would change it. So we have a speed in meters per year. What we want to do is multiply by a fancy 1 that would change meters into kilometers, and that means, of course, there is 1,000 meters in 1 kilometer. So when I multiply this out, I'm going to get kilometers per year. Now, again, that's still not quite what I want. I guess I would also need right here to get rid of years and have seconds. So this is really saying how many seconds are in 1 year. Now, that table actually listed it, and we could look it up, but I'm just going to do a side calculation right here just to kind of emphasize how to convert units. So I'm going to start with 1 year and then say, okay, well, how do I get rid of a year? I can convert it into days because I know there are 365. You could even do a quarter if you want. But there are 365 days in 1 year. So that would convert it to days. Then I would want to get rid of days and convert it into hours. Okay, so it's going to get rid of days. And of course, I have to have 24 hours in one day. So those are equal. That's why this is just multiplying by 1. Just like 365 days is 1 year, so that's just multiplying by 1. So not changing anything. It's still 1 year, but instead of writing it as a year, this much would give me in days, and this much would give me in hours. And continuing on, I might convert hours into minutes. And so this would be 60 minutes in 1 hour. And then finally, converting minutes into seconds. And then this would be 60 seconds in 1 minute. So the hours would go away to minutes, minutes would go away, and now we're going to have so many seconds. And that's what I need to know here. How many seconds are in 1 year? So that's what I need to put here. Okay, so grabbing my calculator, I would go 1 times 365 divided by 1 times 24 divided by 1 times 60 divided by 1 times 60 divided by 1. Yay! All right. So after all of that, I get 3.15 times 10 to, it must be the 7th, because I think I got that memorized. 1, 2, 3, 4, 5, 6, 7. Because it's just, I always remember, it's just a little bit over pi. 3.14 times 10 to the 7th. So, anyways, that's just my silly way of kind of remembering what it is, the number of seconds in a year. But that number is actually in the table. So knowing that, and I think that table actually listed it as 3.16, so maybe they used a quarter there, because it almost rounded up. Actually, I'll try. So I'm going to get rid of the 365 and remultiply by 365 and a quarter. Yeah, and it would just round it up. So I see why they got a 6 there, 3.16. In either case, this finishes the main part of the calculation, where here I could put 1 year, and I could put how many seconds? 3.15 times 10 to the 7th. Okay, so now let's actually do this calculation. So 2 times pi times 1.5 times 10 to the 11th here. And I guess if you want to go divide by 1 times. And that'd be a 1 and divide by 1,000. Then times a 1 and divide by 3.15 times 10 to the 7th. And hit enter. Okay, so it looks like at least to 3 significant figures, although I guess I only remembered it to 2, so I guess I need to do 2 because 2 has an infinite number. It's exactly 2. Pi has 10 because I hit the pi key. Here's 2 significant figures. Here's an infinite, here's an infinite, here's an infinite, here's an infinite, and I rounded it to just 3. But the minimum is the 2, so I guess I need to call that a 30. 30, and then the units would be, let's see back here, kilometer. So year would go away. So kilometers per second. Now the 30 is kind of confusing because that 0 brings up the question. It's always the zeros that bring up the question. Is that 0 a significant figure? Or is it a placeholder? And I guess both would be the answer when it's a placeholder and it's significant. So that's what this is. And so one way to do it is put a line under it, say that's 2 significant figures. Another way is to write it as 3.0 times 10 to the 1 kilometers per hour. And again, when you write it in scientific notation, every digit you write will be significant. So you wouldn't write it otherwise. There's no point in putting that 0 unless you don't mean that it is significant. Either one will work. But just leave it at 30 leaves too much confusion. So don't do that. Either put a line under it or here. Kind of an older notation is to put the period there. But that only helps if, it's appropriate to put the period where it goes. And in this case, it would. But if you had like 300 and you wanted to clarify that that is a significant number, but that is a placeholder, you couldn't put the dot there because that would indicate they're both significant. So the line is the better way to go. It's more universal, more robust. Okay, I think there's more to the problem here because this says the average speed of the Earth as it orbits in kilometers per second. Okay, so I got kilometers per second. And what is it in meters per second? So they were real nice to me in B because converting within the metric system is really nice. And I'm just going to take advantage of what the kilo means. So if I take the 30 and tell myself that I'm just going to replace the symbol K with what it means, which is 1,000, I would then be left with the M, and that's meters per second. So that's the easiest way. And then, of course, you come up with 30 times 1,000, so that's 30,000 meters per second. Again, brings up the question, how many significant figures? And so in my case, like I said, I should have 2. I'll put a line under it right there. Or maybe I'll even write it as 3.0 times 10 to the 4 meters per second. So there's no doubt that there's 2 significant figures. All right. Hope that one's helpful.